So we start off with a picture, right? And then the next thing that they basically give you is an overview, just basically tells you what it does. Of course, we start off with the picture. And let me see if these things will load up. And this is what we gave out in class, which would be what we call the assembly construction. And what is this thing? So this is what y'all use to, so this is what we gave y'all out so y'all can identify where all the sensors was at, right? So this should be like the third page of the book. We okay? Y'all with me? And then we have what we call the input-output modules. So this should be in there somewhere. So this shows us how everything is actually connected to the PLC. So this is the terminal block. So this is the gray cable that plugs into the top, and then this would be what input it goes to. So this would go to D0. So here, this is the way we would program it. So when we program it, we would say use input 0, right? And then we would count the 0 on there, right? Did I show y'all that over there? Over there, it's going to be D0, right? And then it's going to have, then we would look at the numbers on the side of the PLC to come up with this number right there. Does that make sense? Yes or no? And so we would look at the D1 group, and then this would be the 0 light right here, right? Y'all understand that? But there's even a better one in here that we'll look at. So that's IO. The terminal box we don't need to look at. So this just tells us the name of each one of these guys. So this says cylinder 1A is a double acting transverse cylinder. 2A is a vacuum generator with a vacuum coil. And this would give us a good idea when we get into that's the step function chart, right? When they label these different things. And this is basically the same. This is just the same thing, but instead of us having drawing it, this tells us that the start button is connected to what it's labeled on the schematic. It's labeled S3. And it's connected to byte 0, right? Bit 0. Are we okay? Y'all understand those terms? Yes? Because Siemens goes in bytes. And this is the pneumatic diagram. We've already gone over this, so this is pretty simple on this one. We know that each actuator is assigned a circuit, and all the valves and everything that belong to that circuit starts off with the same number, right? Are we okay? And that's pretty standard. I can show y'all. This is the function chart. This is what y'all tried to make over there, but this is the actual one that you can use from now on to troubleshoot. And what do? If we understand the sequence of the thing, and we get down here to it finishes step 4 and doesn't go to step 5, then we would probably look at 1B1, right? And this tells us the input on the PLC. So this is hooked up to byte 1, bit 2, right? And we can see if it's responding or not. This is what Siemens really pushes. These are called step charts. Basically, what they do is they work on steps. So what we do is we put all our actuators over on the left. Then we say we can do two things with these actuators. We can do what? We can either extend them or retract them. The vacuum, we can either turn the vacuum on or off. The pickup cylinder, we're going to either do what? Extend or retract it. And the traverse cylinder, we're going to either extend or retract it. So this says, okay, what we have to understand is that this is actually the actuator in motion. Every line is the step or what's required to make it move to the next step. Does that make sense? So to get this guy right here to start, then 1B1 has got to be what? It's got to be true, right? You understand? If it's true, then this guy right here is going to move. This is when it's in motion. This is what happens when it finishes that motion, which means what? 1B2 would be true. Now this says, okay, 1B2 goes true. Well, what else does that affect? So we follow this line down, and this tells this pickup cylinder to do what? It says, okay, I'm retracted, and it tells it can do what? It can extend. So this is while it's extended, and it moves to step 3. So what these lines are, these are the individual steps. The red lines between the steps that's when the actuators are either in motion or what? Or stationary. So notice this one did what? This one stayed what? Extended, right? This one did what? This one extended. What else? I'm sorry. This one extended, and then it's sitting right here. Okay, so what happens in step 3? Well, 2B2 goes through, which is going to cause this guy right here to do what? It's going to turn on the vacuum. Well, what happened to this guy? Well, this guy stayed, it didn't move, right? You understand that? This guy didn't move, and this guy down here at the bottom didn't move. So what's going to happen when it does this step, right? Vacuum's on. Well, that's going to cause what to happen? Step 4 says, okay, the parts feed cylinder is going to do what? It's going to retract. And it's going to trigger what? 1B1. Okay, does that cause anything to happen? Well, I see these lines and I'll follow that down. This is going to cause what? The pickup cylinder to retract. But this, it's not retracted here. It's going to cause it to retract. So it actually retracts between what? Between step 5 and step 6. So you can't say, I couldn't stay at step 5. If I said at step 5, the pickup cylinder retracts, that would be false. Because it don't do anything at the steps. It does things between the steps, right? Does that make sense? And that's what gets people pretty confused. And this will move over here, right? When this moves, it's going to make 3B1 go true. This is going to cause what? To retract. Well, it's already retracted. It's going to cause it what? To extend, right? See the lines over here? Yeah, extend, right? Which is going to trigger 4B2, which is going to cause what? To extend, right? It's step 8, then it sits there, which is going to cause what to happen? It's going to cause the pressure to turn off, which is going to cause what to happen? Track, right? And all these other ones, I hadn't said that, but all the other ones are just sitting there, right? So this is a step chart, and some people prefer the function chart, some people prefer this chart. So that's why we have 2 of them. It's nice if you have 2 of them, because that way you can do what? You can use whichever one you prefer. Are we okay? So that's step charts. Now the guys that take 2 different directions gets kind of hard. This is the assembly line sequence diagram. I really like this one because this tells me, if I understand these inputs, it tells me when I look at this thing in the start condition, I should look at input byte 0, dot 0, and it should be, that LED should be what? Off, right? And then what? Byte 0, bit 1, that LED should be on. Y'all understand that, what we're saying? So when the input sees a 1, it turns the LED on. It says input byte 1, bit 2 should be on. Byte 1, bit 3 should be off. So right off the bat, I can go over there now and I can look down and see if this thing is ready to do what? Start. And then when I go to step 1, so I put my thing in manual, I hit step 1, then the only thing that's going to change right here is what? Input start. So you're going to have a 1, and when you press it, it's going to go to, it's going to be a 0. When you press it, it's going to go to a 1. And then it would move to the what? To the next step, right? So I should expect these to be the same. So if they don't change, they're going to leave them blank. So all these are going to be the blank on the same, but I should see input 1.2 turn off, and I should see 1.3 turn on, right? You understand that? So if they don't do anything, what does that mean? Yeah, so right now, these all the way down the line, all this LED would be off, right? Until it got into step what? 7, and then it should turn on. So I like this because now you can look at it and say, okay, this is what it's supposed to do. Now, if I had this and it was my personal one, I would probably come down here and take this and move it all the way down. And then that way it would be real easy for me to follow, right? Instead of me trying to come here and say, well, what's it supposed to be? And go all the way to the top. That's what I would do. And this tells us how the outputs are supposed to respond. So when I hit that start button, I should see byte 4 on my outputs. Do what? Bit 5, I should see that light turn on. That makes sense? So I really like that thing. And we don't use these very much. So this is the flow chart. So this is actually literally a flow chart. I'm not going to use that. And then they give us this guy right here. So that gives us the what? The step, the outputs, and then which actuator should. I don't know about that because they're saying 1M1. Okay, 1M1 is not the actuator. This is actually that needs to be reworded. What's the M's? Y'all remember what M's are? Y'all need to learn those. In fact, I think I got a handout on Blackboard. If I don't, I should. Let's see what I have on handout. Oops. This is the solenoid. So M is solenoid. So what are the designators? So A is what? Actuator. What? V is a valve, right? M is a solenoid, right? Z is a B is sensors. Yeah, I just ain't got there yet. I mean, out of the. So here's a Z. There's a Z. What's a Z? No, it's a gauge. Yeah. So it's a gauge. So these are sensors. These are valves, right? These are gauges. Anything else on here? And M's are solenoid, right? And of course, this would also be true on the electrical diagram, but the electrical diagram is just going to show us this. This is a service unit, right? And so a service unit is what actually has the regulator in it, it has the filter in it, it has a pressure gauge in it. And then this is our disconnect right here. So that's what I'm saying. So down here on this one, he calls these right here what? Actuators, but they're not. Yeah, these are actually solenoids that causes the actuator to move, right? So it says to extend in step 1, Q4.5 has to go from a 0 to a 1. I don't know what that means. And then 1M1 would cause this guy right here to extend, which would affect 1B2, and then 1B2 hooks up to byte 1, bit 3 on the input section. Y'all sure y'all understand that? You want to go over and look at the PLCs before y'all go home? Let's go and make sure we do.